Hello my dear family members. As you know, in Capgemini exam, total around 30 pseudo questions are asked. And I guarantee it, if you know bitwise or and operation, logical or and operation, exclusive or operation, right shifting, left shifting, and associativity, then pseudocode is nothing to you. If you don't know how to solve them quickly, then this video is for you. Okay, let's see.
So let's start with the logical OR operation. Logical OR compares two conditions and returns true if at least one of the condition is true, right? So for example, let's say true or false, right? So this will return true because at least one statement is true, right? So in the exam actually you will be given like this. So if 5 greater than 3 or 4 greater than 2, then return or print something, right? So this will return true, right? Actually 5 greater than 3 and 4 greater than 2 both are true, so this will return true, right? If one of the condition is false, then also it will give true statement, right? So this will print. So I hope you got it about the logical OR operation, right? So let's talk about the logical AND operation. In similar way, logical AND compares two conditions and returns true only if both conditions are true, right? For example, if true and true, then only it will return true. If one of the statement is false, then it will give a false statement all total, right? So in exam you will have like this. So if 5 greater than 3 and 4 greater than 5, so this will return actually false, right? Because this statement is true but this statement is false, so this will all total return false, right? So you have to check both condition in case of AND operation, but in case of logical OR operation, if you encounter only one statement is true, then you have not to check the other part or other statement if it is true or not, right? Because if only one statement is true, then we don't have to check the other part, we will return true, right? So I hope you got it. Let's talk about the most important operation in pseudocode, that is bitwise OR operation, right? Bitwise OR compares each bit of two binary numbers and returns 1 if at least one of the corresponding bits is 1. So for example 5 or 3. So binary representation of 5, that is 101, and binary representation of 3, that is 011. So 1 or 1, this will return 1, 0 1, this will return 1, 1 0, this will return 1. Because in case of bitwise OR operation, at least one of the bits should be 1 to be true, right? So 1 1 1. So this is binary representation of 7, so the output will be 7, right? If you can't remember the binary representation of any number, then let me show you. At first start with 0 1 10 11, right? And this will repeat 1 0 0 1 0 1 1 1 0 1 1 1, right? And then it will again repeat 1 0 0 1 0 0 1 1 0 1 0 1 0 1 1, right? Actually this way it will return the binary value, right? 0 1 10 11, this will repeat, right? So remember this way. So this is 0 1 2 3 4 5 6 7 8 9 10 11, right? So I hope you got it, right? Okay, let's talk about the next important operation on pseudocode, that is bitwise AND operation, right? So in case of bitwise AND operation, it compares each bit of two binary numbers and returns 1 only if both corresponding bits are 1. So for example 5 and 3. So here binary representation of 5, that is 101, and 3 011, right? So 1 and 1, that is 1 1 0 0 1 0 0, right? So both statements should be true for the statement to be true, right? So this is true, that's why the output is true, right? If one of the statement is false, then the full output will be 0, right? So this is the binary representation of 1, so output will be 1, right? So I hope you got it. This way you have to solve the problem. Okay, let's talk about the next most important operation on pseudocode, that is bitwise XOR operation, right? Exclusive OR operation. So In case of bitwise XOR operation, it compares each bit of two binary numbers and returns 1 if the bits are different, that is 0 and other is 1, right? So if both the bit are 1 or both the statement both the bit are 0, then this will return 0, right? So only in case of different bit it will return 1, right? So let's take an example. Let's say 5 XOR 3, right? So binary representation of 5, that is 101, and binary representation of 3, that is 011. So in case of XOR operation, both statement if different, then this will return 1, right? And if both statement are both the bits are same, then this will return 0. So this is the binary representation of 6, right? So this will be 6. So I hope you got it, right? If you face any problem, then let me know. I will be there with you, right? So let's talk about the next most important topic, that is left shift and right shift. But before we proceed to the explanation, I would request you to please subscribe this channel and watch the playlist regarding Accenture on-campus coding question or Accenture assessment based question, right? So let's talk about the left shift operation, right? So left shift moves all the bits of a binary number to the left by a specified number of position. It effectively multiplies the number by 2 for each shift left, right? So for example, 5 left shifting by 2 bit, right? So it will result into 20. How I am explaining. So what is the binary representation of 5? That is 101. So we are left shifting by 2, right? So it will left shift by 2 position. So this will result into this, right? So here 2 blank space will be there. So this will be 20. So this is the 20 in decimal value, right? So that's why the output is 20. So let's take another example. Let's say 20 left shift by 2. So what is the binary representation of 20? That is 10100. So if we do left shift operation, then it will left shift by 2, then this will and 2 blank space will be more here. So the output will be 10100 and 2 more 0, right? So this will be the value of 80, right? So what is the shortcut to solve the problem? So for example, 20 left shifting by n element, right? So 20 multiply by 2 to the power n, right? So if n is equal to 2, then output will be 20 multiply by 2 to the power 4, that is 4. So 20 multiplied by 4 is equal to 80, right? So for example, 5 left shifting by 2, so 5 multiplied by 2 to the power 2, that is 4, that is 20, right? So I hope you got it, right? So let's talk about the right shifting element. So in right shift moves all the bits of a binary number to the right by a specified number of position. It effectively divides the number by 2 for each shift writing, right? So for example, 20 greater 2, I mean right shifting by 2 bits. So in this case, output will be 5, because the binary representation of 20, that is 10100. And if we do right shifting, then this will be right shifted and the output will be 101, right? So this way actually the output will be 5. So in the case of first condition that we took, so for another example, let's say 5 greater 2, I mean right shifting by 2. So binary representation of 5, that is 101. If we right shift by 2, then this will be right shifted and the output will be 1. I mean the value of 1 is also, but the binary number is 1. So how to solve them quickly? So for any number, let's say 20 right shifting by n element, so output will be 20 by 2 to the power n, right? So if let's say n is equal to 2, then output should be what? 20 by 2 to the power 4, that is 4. So 20 by 4 is equal to 5. And for another example we took, that is 5 right shifting by 2. So this way also 5 by 2 to the power 2. So 4 is equal to 1, right? So this way we will solve the problem very fast, right? So I hope you got it right. And one important thing at the last I have to tell you, that is, whenever you will see a big pseudocode problem, then don't skip it. There are 90% possibilities that there are some if conditions will be there. So if conditions are not going to be true, right, so you will have to just directly print the value. So don't skip the big pseudocode. Actually they will take lesser time than the smaller pseudocode, right? So I hope you will give importance whatever I have told in this session. So if you love this session, then please subscribe this channel, and if you want more content, then please suggest me in the comment section. Okay, thank you for today's session.